Okay. So just quickly, Mars 101. Here's a nice view comparing the two planets. Which is which? Okay, Earth on the left, Mars on the right. What do you see? What do you see about Mars compared to the Earth? Smaller. Okay. It's smaller. What else?
Desolate.
Desolate. Desolate is kind of an interesting descriptor. How do you, what do you mean by desolate?
It looks kind of dead. Looks empty.
Looks kind of dead? Okay.
Like you look at Earth and you see, I mean, the clouds and the blue, you think of life.
Okay, the blue on Earth is what?
It's water.
Water. Any blue on Mars? No. Okay. So clearly there's no oceans on Mars. What about clouds? I mean, there are clouds. We've got some clouds here. We've got some clouds here. We've got clouds that are hanging out over these volcanoes that we'll talk about later. Mars is smaller. The landmass on Mars is actually about the same as the landmass on the Earth. So what's really missing, surface-wise, is the oceans. What about Mars is the red planet? I think it's more butterscotchy, okay? But we'll talk about that as well. Okay, so here are just some more differences. We've already talked about some of these a little bit. Both Mars and Earth are tilted on their axes, about the same amount right now, actually. And what does axial tilt of the Earth give us? Seasons. So Mars is tilted on its axis. What could we expect about Mars? Seasons. What about the year on Mars? The year on Mars is not quite twice the length of the year on the Earth. The day on Mars is a little more than a half an hour longer than the day on the Earth, so it's spinning around on its axis about the same time. Gravity is about a third of the Earth. Sunlight is less because further away from the sun. And the solar intensity drops off as the square of distance away from a light source. So the further away you get from the sun, the dimmer and dimmer planets become. Now, we have plenty of plants that grow in the understory of tropical forests that have much less light than this. So, 44% of the light that's present on Earth is not any kind of game killer, any game stopper. The atmosphere is quite a bit different between the two. Primary component of the atmosphere on Earth is nitrogen and about 20% oxygen. Atmosphere on Mars is mostly carbon dioxide. But what's really different is that the atmosphere of Mars is just incredibly thinner. It's less than 1% of the thickness of the atmosphere on the Earth. So just quickly, in some respects, Mars is fairly like Earth. And some of the things we've already talked about. It's just a little bit further out from the sun. Its day length is not that different. So, we could live on Mars and have a normal day-night kind of cycle. Not like on the moon or some other bodies. Orbital period is longer because it's further out. Mars's orbit is more eccentric, more squished, more oval-shaped, more elliptical than the Earth's. But again, the same kind of tilt to the planet. And, a third of the gravity of the Earth, that's nothing really outlandish. It's not like we'd be squashed flat to the planet from high gravity or floating off into space. So those are all aspects of Mars that are kind of okay. But in many respects, Mars is still an alien planet, and I want to reinforce that right up front. Mars is much colder. The average temperature on the Earth is about 15 degrees Celsius. That's due to not only our location as the third planet out from the sun in the habitable zone, but also due to the amount of natural greenhouse effect that we have from the water vapor and carbon dioxide that are naturally in our atmosphere. Mars is much, much colder. Now it will occasionally, in certain locations at certain seasons, like if you're on the equator during the summer at low elevation, you might get above freezing temperature. But you also can get temperatures that are 200 degrees below 0 Celsius, which is colder than anything Antarctica or Siberia has to offer here on the Earth. As I said, the atmosphere is much thinner, less than 1% of the atmosphere of the Earth. And because the air is thin, there is no liquid water present on the surface of Mars, at least in any extended time period. If you threw out, or if you set out a pan of water on Mars, it would be a race to see whether the water would freeze or boil away first. Okay? Because of the low atmospheric pressure, just as you go up in elevation, like if you were trying to boil water in Denver, which is a mile high, it boils at a much lower temperature than at sea level. Well, think of Mars as mile high on steroids, and so boiling point of water is very low, and actually there is no stable point for liquid water on the surface of Mars today, at least. Air is unbreathable. There's no global magnetic field on Mars as there is on the Earth, and we'll talk about that a lot more when we talk about the geology section. What does our magnetic field get us? Oh, I can use a compass. No, really, what does our magnetic field get us? Well, it actually does help hold in the atmosphere because the magnetic field shields the Earth from what? That would, radiation, solar wind, got all these, the sun is constantly emitting these energetic particles, they're streaming through our solar system. We've got a global magnetic field which tends to shelter us on the surface from that, and Mars doesn't. And so Mars, the surface of Mars, the atmosphere of Mars has been exposed to the solar wind, to the radiation from the sun for billions of years, and that's probably a big part of why it has very little atmosphere left today. We'll talk about this as well during the geology section. The Earth has plate tectonics, Mars currently doesn't, and we'll talk about why that's important later. So here's Earth and Mars again. Here is a desert scene on Earth. Anybody recognize this particular desert? It's got saguaro cactus in it. This is actually the Sonoran Desert in southern Arizona, northern Mexico, northwestern Mexico. And, it's desert, which means it's dry. But compared to Mars, it's a lush garden, right? So here's the Pathfinder site where the Pathfinder lander and Sojourner rover landed in '96. What do you see? Rocks? Somebody said rocks? Rocks, sand, rocks and more sand and some more sand, and there's some more rocks. And okay. So you got to love your geology. Mars is as Elon Musk has said in many interviews, Mars is a real fixer-upper of a planet. And so we'll talk about that as well. But, I did want to show you, we are beginning to get some experience with what it's like on Mars in an up-close and personal perspective. We'll talk about different kinds of missions that go to Mars, those that are initial flyby missions where we first scouted out the planet. The orbiter missions that we continue to use today because they provide us a global perspective. But we're getting more and more experience with what different landscapes look like on Mars. Here's the Viking 1 landing site, the first successful landing of U.S. probe on Mars. The Soviets actually landed a probe in the same launch window as Viking 1, but it only functioned for a few minutes before crapping out. So this is really the first successful lander. Here is the Chryse Planitia landing site. What do you see? Dust, rocks, different kinds of rocks maybe. You see where the probe has scooped up soil samples, although we don't call it soil, to check for life, and we'll talk about that later as well. Viking 2 landed in Utopia Planitia. And all of you Star Trek fans, what's the importance of Utopia Planitia? No Trekkies in the room, huh? That's where the Enterprise was constructed in the shipyards of Utopia Planitia. You guys lead a sheltered life. I must say that as we've landed more probes, as we've gotten better able to land probes, and we've been able to land probes on more interesting terrains, the landscapes started looking more and more interesting. Here is Endurance Crater in Meridiani Planum, one of the places where the Opportunity rover spent a year and a half, 2 years poking around, doing studies, measuring different samples and so forth. Now Opportunity is going to spend the rest of its useful life at Endeavour Crater, which is this huge hole in the ground that will keep it busy for longer than the mission or the machine will hold out. But you begin to see more kind of here's a vista. There's mountains off in the distance. Those mountains are the far rim of the crater. So this is one big whopping crater. Here is a shot by the Spirit rover, who spent much of its time doing mountain climbing, which was not really on the initial bill for the mission. So this is at the top of Husband Hill, named after one of the Columbia shuttle astronauts, the commander, looking down off into the distance. The Phoenix lander landed up in the North Polar region. Frankly, boring. Okay. This was meant to be a boring site because mainly what the probe was interested in was scooping down underneath the surface to look for frozen water and not take pretty pictures of any place that you'd ever want to visit. But there's some interesting geological features in terms of the way that the frost heaving has worked on the ground, very similar to what we see on the Earth. And we may spend some time talking about what that means in relationship to where we can find water on Mars today later. What's our latest rover on Mars? Curiosity. And where's Curiosity landed? Curiosity's landed in Gale Crater, which it has this huge mountain in the middle of it, which is the target of Curiosity's explorations. And this is not quite an accurate color picture. This has been white adjusted to appear the way the landscape would look like on Earth, so that geologists can look at it and apply their understanding of Earth formations to, an analysis of what the images are showing.